Area of other figures. Now, the figures we've already worked with are things like rectangles, parallelograms, and triangles, and those are ones that you probably are familiar with before. Now we're moving into more complex figures, such as trapezoids and other things that look kind of funky, but if you break it down into pieces, you can figure it out normally. Key idea is to figure out how to break down the figures into the pieces that you already know the formulas for. Now, the area of a trapezoid is sort of like the area of a triangle because you have it, and it's sort of like the area of a parallelogram, but with two bases. So the easiest way is to just demonstrate. So here, if you look here closely, what we have here is we have um, the area of a trapezoid. And the first step you do, what you do is you go ahead and you duplicate the trapezoid. So you have this trapezoid here, you make a second copy of it. So then you flip this one, so you flip this one here upside down, and so now you connect them. And when you do this, you will always end up with a parallelogram. That's just the way it works. With a trapezoid, you have two bases, base 1 and base 2, and a height, just like with a parallelogram. So, but in a trapezoid, because you just have one set of parallel sides with a trapezoid, so therefore the height is always going to be the distance between that set of parallel sides. So the area is just going to be, of this trapezoid, the area is just going to be equal to this base 1, or base 2, plus base 1. You add those two together, then you multiply that times the height, and so now you get the area of this entire big parallelogram. But we don't want that. We want half of it because we only have one of these, not two of these. We doubled it, so now we have to have it again. So it's just going to be base 2, so that's from here to here, plus base 1, so from here to here, and then times the height, so here to here, and then you just half it because you flip it over. So as an example here, for these ones here, they're in this lovely black and blue format already. So you got base 1, that's 10, and it doesn't matter if you do base 1 or base 2 first. 10 plus 4, so that's going to be the base 1 plus base 2 part. That's going to be times 2, which is the height. Then that's going to be times a half. So when you multiply this all out, you're going to end up with, and really there should be units here, maybe centimeters or something like that, but they don't have them here. So, but don't forget to do that when you actually have the problems have the units on there to include them. So this is going to be 14 times 2, 28 divided by 2 is going to be 14. So the area of this is going to be 14. Now over here and here, these are a little bit trickier because this one here, you can't actually figure out because, yeah, you've got something connects the two parallel sides, but that's not the actual height. That is at an angle. It's not perpendicular, so that's a tricky problem. If you were given this, there's no way to possibly figure this out. If you were given this is extra measures here. We got this 3 here and this 4 here. We don't need that 3 or the 4. All we need is the 26, the 10, and the 7. And so then all we do is 26 plus, that's base 2 or base 1, it doesn't matter what order you put them in, plus 10 times the height, which is going to be 7, times 1 half. And when you figure that out, well, it's going to be, this is 10 here, not 16. Okay, 36 times 7, whatever that is, divided by 2. So it's just going to be, and you can do this quickly, 18 times 7, because 36 divided by 2 is going to be 18. So it's going to be, well, 56. So it's going to be 126 units of whatever type it is. So that's basically the area of trapezoids. Now, these look all funky. As a matter of fact, this reminds me of like a miniature golf course, which I love miniature golf. It's kind of fun. You can always visualize there being like holes over here somewhere, and funky sort of obstacles in between, like this one here. You have something on the side to bounce it off of. But But what you need to do is you need to start looking at these things and say, okay, how can I break these down into figures I actually know? Well, this here is a trapezoid solved as base 1 plus base 2 times this times a half. So that's pretty easy. So it's just going to be 24 because 9 plus 15 is 24 times this divided by 2. Now, these ones here are a little bit tougher, but not if you just, like I said, break it down. See how you can make it into shapes you already know. Now, if I were to do that, now I got a rectangle and a triangle. If I do this, I got a triangle and a rectangle. Again, my drawing could be a little bit better, but if I do this over here, if I did this in a better straight line, but I have a rectangle and a parallelogram. If I do this here, and sometimes there's different ways of doing this. I could go ahead and have it be like this, have triangle, triangle, and rectangle. Or if I wanted to do it even a little bit differently, I could just go ahead and say, okay, now I got a trapezoid triangle. And here again, same thing. Or alternatively, I could just do it this way, trapezoid triangle. For here, I'm just going to have a bunch of rectangles. And you just have to really look at how to break these down into pieces that you actually know. So here I've got two triangles. And then you just figure out the area of each individual piece. This times this is going to be the area of this rectangle. That's going to be 48 meters squared. Now, sometimes these get a little bit tricky, but they're actually not really all that tricky. What's the base of this triangle going to be? It's going to be 12. That's what the base is. What's the height of this triangle going to be? We don't have the height actually listed, but we are given enough information to figure it out. We got 10 here from here to here. We got 4 here. So what's this height going to be? It's going to be 6. So it's going to be 12 times 6 times 1/2. Because remember, the area of a triangle, 1/2 base times height. We can do this the same way. This is just 1/2 base. The base times the height times 1/2. It's the same way. Just you can go ahead and mix up multiplication as long as you do it the right way. Eventually, then you'll end up with the same answer. So I just switched it around a little bit. So this is going to be 72 halved. It's going to be 36. Remember, we got to include our meters squared. But then the other important thing is you got to remember to add them up. So 36 plus 48 is going to be, well, 14, and then you got, so it's going to be 84 meters squared. This all is the problem on this part of the board here. So meters squared. Well, you get that idea there. And so that's how you break these down. And just as an example I'll do one more here, but this is just, again, looking and seeing how to do it. So for example, this one here, do we have the numbers to be able to do it? Well, let's see. We've got base 1 here. This is going to be 20 for base 1. What's the base 2? Well, it's going to be 20 plus 16, because that goes all the way from here all the way up. So that's 36. That's going to be, add them together, times the height, which is going to be 18. Then you half that. And you got all this area now. Get all that filled in. Now we just need to do the actual multiplication and figure out here of the height of this triangle. Height of this triangle is going to be 16 meters times 8 times 1/2 again. When that happens, you got your answer. And then you add them both up together and you come up with your final answer. Just use the shapes you know, because really it should be something when you see this stuff, it may take a little bit of time to get practiced in it, but once you see it, then it's like an aha moment. Oh, I can break this down into those shapes and then figure it out. Just make sure to add up the pieces and make sure to do it methodically into steps, just like I did here. 1 step and 2 steps. Then make sure to add them at the end.